All right. So still 14. Anyway, we will start without the other one or without the other two. So this is where we stop. So can you guys see my screen now?
Yes, sir.
Yes, sir. Yes.
So again, we have this given example a while ago. So 2, 6, 18, 54, and then 162. And then just by applying this formula, then you will be able to get the following numbers. Okay. So in here, we already know the a sub 0, which is 2. So for us to be able to know how did we get the second value, which is a sub 1, so just multiply or just find the multiplier since we are in geometric sequence. Okay, so the multiplier to get the 6 is 3. So 2 times 3 is 6. So we have to prove the following equation whether this one is really true or no from or for the following equation. So 2 times 3 raised to 1 is 6, and then 2 times 3 raised to 2 is equal to 18. So as you can see, this is the a sub 0, a sub 1, a sub 2, a sub 3, a sub 4. So those are their positions. So a sub 0, a sub 1, a sub 2, a sub 3, a sub 4. So is it true up to a sub 4? So just by substituting this one or just by following this formula. So 2 times 3 raised to 4 is 162. So from here, we have proven that your A is really 2, and then your R here or your multiplier here is really 3. Okay, and so on and so forth. So I just didn't show the following terms after 162. So the first 5 terms only. All right, and then from here, okay, so this one is a fixed value. Okay, so if you're going to apply this one, okay, and then it's starting from 0, then you can use this one. So by default, A is equal to 1, and then R is equal to 2. Okay, so the only thing that matters is as long as you know the maximum limit, okay, which is this one. So 13 plus 1, so just keep on adding 1. So 2 raised to 14 minus 1. So if this is 17, so or your let's say your maximum limit is 17, so just add 1. Okay, so 2 raised to 18 minus 1, then you will get the geometric sum of this given equation. All right, so as usual, once you're done in understanding this one for this formula instead for geometric sequence, then you can now proceed and start answering the seat break number 4. So the same with our example, what is the value of A? So this is like a bonus already. You already know the value of A from number 1 and number 2. But what is R for this given sequence? Okay. So this will only take you maybe more or less 5 minutes. So you can do the same, just like this example. So you can already answer your A, and then identify what is your multiplier or what is your R. Okay, and then you have to prove uh, that one using the equation. So A sub 0, or just by using this formula, A times R raised to I, to get the A sub 0, A sub 1, and so on and so forth. So is this clear so far?
Yes, sir.
How
Yes,
about
sir.
the
Clear
others?
naman po.
Yes?
Yes, sir.
Yes, sir.
All right. Okay. So we also have here the double summation. Okay, and then at the same time your seat break number 5. So evaluate the following equation. So initially we have this one. we have double summation. So we have letter I and then letter J. Okay. So summation from I or from I to 4. Okay. And then summation from J to 3. Okay. So both of them started with 1. So you can simplify this one just by distributing your letter J first. Okay. So as you can see, we retain this summation I up to 4 and then just distribute the value from 1 to 3. Okay. So take note, since this one is summation, so we will use addition. Okay. So I plus 2I plus 3I. So where did this value came from? So it's from 1 to 3. So it's like 1I. So basically 1I is just the same with I. So we just remove the 1 plus 2I, which is now your second term, and then plus 3I, which is now your last term. So you can simplify this one a little bit more. So just add everything. So I plus 2I plus 3I is equal to 6I. So once you already have this one, then you can now distribute your I. So again, this one is ranging, or this I is ranging from 1 to 4, or summation from 1 to 4. So, just substitute their corresponding values. So 6, which is this one, and then your I here is a summation of 1 to 4. So times 1 plus 2 plus 3 plus 4. And then if you're going to simplify this one, then you will get 60. Okay, so that's how you simplify a double summation. This one is actually quite simple. Then, after you were able to understand this one, then you may now proceed in seat break number 5, wherein you're just going to evaluate a double summation, but just a different starting point and a different upper limit. So you can do this one handwritten. Then again, please write logically. Okay.
Excuse me, sir. Since this one is not starting at the same point, how do we attend to this?
If they are not the same,
Yeah,
the same what? Not the same in terms of.
starting point. For the example, I equals to 1, J equals to 1. But for the seat work, I equals to 0, J equals to 1.
So that is the twist part. Okay, so it is now your uh, research work on how you will identify if it's not starting with 1. Okay, I think it's quite the same. Okay, so instead of having this I here, so what will you get? 0 times I. But in here, since we've started with 1, so 1 times I, which is the same with I. I think that's the only difference. Can you understand it now? Add this a little. So if not,
Just a little.
just a little. So if not, there are lots more examples from the internet, but this one is the simplest form when it comes to double summation. So there are others which are more complicated. But if you can find something like this, okay, wherein we have a starting point of 0 or starting point of 2, then same format. Okay. You can follow this one as it is. All right. So any other concerns so far?
No, sir.
All right. So let's now proceed to the last topic, so which is strings. So this one is a sequences of letters or other symbols written without the commas. So it is the opposite, or It is the way on how to get the sequence into a certain word or a certain letter. So for example, we have this sequence STURDY. So the string of that one is 1. So just simply removing the comma. Okay. We call this one string or a word or what's one? A text. Okay. So we simply removing the comma. So the same with this one, just remove the comma. Okay. So they know this is a sequence, and then this is now the string format. Just by removing the comma, and you will get the string format right away. Okay. So what is this string format for? So what is saying it's a set corresponding to a sequence. So it is set of all these string elements in a sequence. Wherein, if you're going to recall, in a string or in a set rather, in a set, it is separated by comma. Okay, but this one now, if there is no close and open parenthesis, close and open bracket rather, this one now is the sequence. And then if you're going to transform this one into string, then just remove the comma. Okay, so this is the set, and then this is the sequence, and then just remove the comma 1491625, then that is now the string format. Okay, so it's like basically transforming a set into a sequence into a string. Okay, that's the origin. Okay, so the same with this one. So we have this set, and then we have this sequence or string rather. Okay, this is already a string because there is no comma in here anymore. Right, so just take note that in sequence, the order of the elements is important. Okay, so in here you cannot shuffle this one. Okay, but in set, of course, you can shuffle it. So 25, 4, 9, 1, 16. So regardless of the arrangement. But for sequence, so whatever is the first one, it should stay as it is. Okay, don't put the second term on the first term, or do not put the last term on the first term. So in a sequence, order is very important. But for the set, again, it's not important. Okay. The elements order is insignificant. Order I, the elements order is is insignificant. Okay. So number 3 here is like an example. So give 3 different sequences that have X, Y, Z. So this is a set wherein arrangement doesn't matter. So the question here is give 3 different sequences that have X, Y, and Z as corresponding set. So what are those sequences? Anyone can give? So I'll just write it here, but I'll erase it later on. So for your first sequence, so you can have Z, Y, X, okay? Or you can have X, Y, Z. Or you can have Y, Z, X. So those are the 3 sequences. So Z first, and then X first, and then Y first. So those 3 are different when it comes to sequences, but of course, when it comes to a set, they are just the same. But then again, since arrangement matters in a sequence, so those 3 are 3 different sequences. Okay, so are we clear so far regarding with strings and sets and sequences?
Yes, sir.
Yes, sir.
Opo.
All right. Okay, so let's have more examples when it comes to a string. So give the set corresponding to the sequence. So this is sequence, and then here's the set. So you already know this one. So again, in a sequence, this is the format. So that's your arrangement. So we don't arrange it anymore since that's the default one. So the question here is the set. So what is the set out of the sequence? So again, in a set, there is no repeated values. So you should only put one, and you should only put uh, 1, 2. Okay, 1, 1, and then 1, 2. That's why we have 1, 2. So you can answer here 1, 2, or 2, 1. So doesn't matter since this one is a set. And then we have here the sequence, and then we have here the set. So as you can see, the only difference here is the close and open bracket, and then the arrangement when it comes to the sequence. And then at the same time, for the set, of course, you have to remove the repeated values. So since there is no repeated values here, so just copy as it is and then just put it inside the bracket. So this is now a set. Okay. So we also have this one from AA, BB to ZZ. So since there is no repeated elements, so you can just copy as it is and then put it inside a close and open bracket. All right. So any questions so far?
No, sir.
Wala naman po, sir.
All right. So let's have more example, which is the most origin when it comes to string. So the string with no elements is denoted by this. I don't know if this is lambda. Forgot. So we have this symbol wherein indicating that there is no elements or there are no string on that given sequence. So actually it's nothing. Okay. So this one is the same with null or empty set when it comes to set operations. But for string, we have this symbol. Okay. And then the length of the string is denoted by this. It's like the same. So we have this, what do you call this one? Forget that term. The, what is that again in this set operation? Cardinality. Okay.
The cardinality.
Yeah, cardinality is the count of total of elements inside of that set. So we also have the same when it comes to string. And then we have this one special symbol wherein X, and then it has an asterisk on right, upper right. So this one denotes the set of all strings over, over X, okay, or over this symbol or variable rather. And then we have this plus, okay. This one denotes the set of all non-null strings over X. Okay. So let's have an example for you to be able to understand what are those given symbols. So let X is equal to a set of AB. Okay. And then some elements of X asterisk. Okay. So if we have this kind of symbol asterisk, you have to identify all of the possible strings over this variable, which is your X. Okay. So from here, we could say that we have the empty set, okay, or the null set in set operations or lambda. And then we have here the A, and then the B, and then AB, B raised to 20, A raised to 5, and then B, A. Okay. So if you're going to take a look at this one, all of this can be inside of this set. Okay. No matter how many 20s or how many B's you have. So we have 20B, we have 5 B's, and then followed by 1B and then 1A. And then we have AB, which is just the same with this one. So maybe you're wondering where this one came from or where those two came from. So actually, it's just an exaggeration. Okay. So this one is a set of all strings over X. So we could say that this one has no limitation. So you can have 1,000 or 1 million A's, or you can have 2 billion B's. Okay, just to indicate that it's all elements or all strings under such variable. So initially you can just have this one lambda and then a and then b, since that is what's really inside of this set. At the same time we have this one. Anyway, so let's have this example. If alpha is equal to AAB and beta is equal to A raised to 3, B raised to 4, A raised to 32, then alpha, or the cardinality of alpha, is 3, and then the cardinality of beta is 39. So why 39? So just simply add the exponents of those given variables or given elements. Okay, so this one is an indicator that we have 3 A's, 4 B's, and then 32 A's. Okay, so of course, since we are in a sequence, so we have to count everything. Okay, so we have 3 plus 4 plus 32, which is equal to 39. Right? So are we clear so far regarding with this example? No? Are you guys still there?
Yes, sir.
Yes, sir.
All right. So do not mind this one. Okay, this one just might confuse you. Anyway, this one is, just to indicate that you can have many A's, you can have many B's. This is just the same with this one. Right? And then this is how you count the cardinalities of a given string. Okay, the next one is concatenation. So you guys already know what is concatenation. So for example, if alpha and beta are two strings, the string consisting of alpha followed by beta, written as alpha beta, known as concatenation. So as you can see, we have two different strings, and then just by simply concatenating them, or just by putting them aside or side by side, alpha beta, we call that one concatenation. Okay, so we have this example. We have this, I don't know what is the name of this symbol, which is containing AEB. And then we have this one. Is this omega? The W? Or no? Omega is, yeah, this one is not omega. Anyway, this one has a string of CABB. Okay, so it is asking us to concatenate those two symbols. So this one first, and then followed by this symbol. So what is the value or the content or the string of this one? So it's AAB, and then followed by CABD, which is this symbol. Oops. And then the last one here, sorry, the second to the last is the, so instead of having this one at first, we have this one at the last, and then instead of having this one at the last, we have this one at the first. So they just interchange. So of course, CABB followed by AAB. Okay. So just simply, put them side by side, depending on their arrangement, of course. And then we have this symbol, which is this one. And then we have this lambda. Okay. So lambda here is no elements. So you can just simply remove that one and then retain this one. Okay, so what is the string value of this one? So it's A, B. All right. So that's how you concatenate a string. Okay. Super easy. It's like a bonus already. So any questions so far?
No, sir.
Wala naman po, sir.
All right. So strings are just like a bonus. Okay, this one is super easy. Anyway, once you're done in understanding those examples and concatenations, then you can now proceed and answer the seat break number 6. So find, so we have this given sequence. So find S of 1, S of 4, and then write as a string. So take note, this is just a sequence. Write this one using in a string format. All right. So that's it for the module 3. So any question or clarification so far?
Wala naman po,
Sir.
sir.
Answer.
Right. So if you have a question or clarification in the future, then feel free to ask me anytime. So you can chat me or message me via Canvas or through my Facebook account. All right. So if you guys do not have a question anymore, then that's it for the module 3. Then just answer the activities on our Canvas. So next meeting, we will finish the module 4. All right. So goodbye and thank you for coming. Okay.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank
Thank you, sir.
Sir. Sir, pwede na malis, sir.
Yes, yes. So you guys may now go.
Thank you, sir. Bye po.
Goodbye.